Today we're going to be talking about linear inequalities. This is kind of like a little bit of review before we jump into systems of linear inequalities. So when we're talking about linear inequalities, the first thing we may need to do is to verify that our solution is true. Checking to see if it works, maybe identifying maybe where we made a mistake. So the first two problems. So first one, we have y is greater than x minus 3. I want to know if any of these points, or all of them, work. So how do we do that? We plug the numbers in. We have x and y, plug it in. Remember, make sure you put them in the right spots. So you have negative 7 greater than negative 3 minus 3. And negative 3 minus 3 is negative 6. Is negative 7 greater than negative 6? No. So that one's not a solution. Let's try 5 and 10. 10 in for the y, greater than 5 minus 3. Is 10 greater than 2? That one is a solution. What about 7 and 4? Plug the 4 in. 7 minus 3. And we get 4 is greater than 4. Now, is 4 greater than 4? No. It's equal to, but it's not greater than. If there was a line under here, then it would be a solution. The only way this would work, if this number is the same as that number, is if there's a line under there. So now we go to another problem. So this top one was in slope-intercept form. Get used to seeing X. We're going to be doing that a lot more leading into the next lesson. This is in standard form. 3x plus 2y is less than or equal to 15. We want to check 3 more points. Do it the same way. We still plug these numbers in to our x's and y's. So we have 3 times negative 2 plus 2 times 8 less than or equal to 15. Negative 6 plus 16. And we get 10 less than or equal to 15. Is this true? Yes, it is. So that one works. Let's try 10 and negative 5. 3 times 10 plus 2 times negative 5 is less than or equal to 15. 30 minus 10 less than or equal to 15. We get 20 less than or equal to 15. Does this work? Is this true? No. So that point doesn't work. I'm going to erase this just so you can work on this last problem. Three times negative 4 plus 2 times negative 1 less than or equal to 15. Negative 12 plus negative 2. We end up with negative 14 less than 15. Obviously, a negative number is less than a positive number. So I know this point works as well. So in both problems, or in the first one, only one point worked. In the second problem, 2 of these points work. So in the future, maybe you have 4 options. They could all work, or none of them couldn't work. You have to try and test them out to see if it works or not. The next part of the lesson involves our graphing. So there's really no way to write out and prove a linear inequality given it in 2 dimensions, or a system that we're going to be leading into. So we need to graph it. So we're going to start off by thinking about what we know and comparing these things. So there's a little chart in your notes. It kind of looks like this. Less than or greater than. We have a less than or equal to, or greater than or equal to. Again, we have less than or equal to, and we have a greater than or greater than or equal to sign. So kind of 4 rows there. Now, in a one-dimensional scenario, when I mean one-dimensional, I mean one variable. Kind of like an x greater than 5. Something like that in one variable. When we graph this, if it was a less than or greater than sign, we used an open circle. If it was less than or equal to or greater than or equal to, we used a closed circle. If it was less than or equal to, we shaded to the left. And if it was greater than or equal to, we shaded to the right. So all that's review. All that we've done, a lot in Algebra 1, and I think we even touched on it here in Algebra 2 earlier in the year. Now what happens if it's in 2 dimensions? Something like the problems we were just doing, where it was y is greater than or equal to 3x plus 1. Something like this. So this is 2 dimensions because it has 2 variables in it. Now, instead of doing open circles, because these are actual a point on the line. This, we're comparing the line. So we can't make open circles on a line. But how we represent something with a less than or greater than sign would be a dashed line when we draw it. So instead of drawing something straight through, it's going to look something like this. A dashed line. That's how we would represent it. And that means a solution right on this line is not a solution. It's kind of like an infinite number of open circles going up. If it's less than or equal to or greater than or equal to, instead of closed circle, we will use a solid line when we graph. So again, it's just going to be a solid line like this. Now, when it comes to shading, if it's less than or equal to, instead of shading left and right, we are going to shade below the line. So, we just go below it. Find the line and go straight down. Instead of shading to the right, if it's greater than or equal to, we're going to shade above the line. Okay, so we're comparing our y value. Remember, y values go up and down. So, pause this, copy this chart down, keep it handy by you. Keep this as a little reference. Again, this is your main reference solving these problems. So now we're going to look at some of these. So we're going to look at letter A first. And remember, when we're graphing, not necessarily need to see all the little hash marks in our graphs or anything like that. We're looking for whether it's a solid line or dashed line, kind of the direction of the line, whether we're shading above it or below it. So here's letter A. We have y less than or equal to 2x plus 5. Now remember when we're graphing, when it's in slope-intercept form, we start at the y-intercept. So we're going to start at 5. Somewhere around there. And if our slope is 2. So we identify that our b value is 5, our n value is 2 over 1. So I'm going to go up 2 over 1. Up 2 over 1. We can see the direction of our line. Now this is where it's different than an equation. Less than or equal to, if you look back at your chart, that means this is a solid line. And it says less than, which means we shade below the line. Think about numbers going down when it's less than. So everything in here, under this line, is a solution. When we graph these, it's going to split the graph into 2 halves. Half of it down here shaded, the other half above it is not. So what does that mean? That means that any point under here is a solution. So if I pick the origin right here, This point is 0, 0. I know this will make it true. Is 0 less than or equal to 5? Yes. This point here, maybe this is 5, 0. This works. This point here, maybe this is -2, -4. That works. The point here works. The point here works. All these different points are possible solutions. Let's look at letter B. We have y less than -2/3 x plus 5. So again, we start with our y-intercept. Our b value is 5. So again, I'm starting up 5. My slope is -2/3. Down 2 over 3. Down 2 over 3. Now because it's less than, it doesn't have the bar under it. This makes this a dashed line. So which means, if one of these, like the points that I graphed, started using, these are not solutions. These will make it like 10 is less than 10. That's not true. Or 15 is less than 15. Not true. So anything on this dashed line is not a solution. Now when we shade this again, less than, I'm going down. So all of this down here is a solution. You don't have to shade it in completely, again, if you're just using a pen or pencil, but we can see that all these solutions are true down here. So any point you can come up with down here would be a solution. Now let's look at another problem. Let's look at letter E. Now letter E is not in slope-intercept form. So we have to change this. We need to put it in slope-intercept form. Here's letter E. It is -2x plus 4y is greater than 12. So I need to get the y by itself. I need the y and then my x's and everything over here. So again, because I have this quantity, -2x, is being added to 4y, I have to add this opposite. Opposite is positive 2x. We get 4y greater than 2x plus 12. Divide everything by 4. This ends up just being y. I do not have to change the direction because I did not divide by negative. 2 over 4 is just 1/2 x, and 12 over 4 is 3. Now we can graph this. Y-intercept is 3. So again, I'm starting up here. My slope is up 1 over 2. It's just a greater than sign, which means this has to be a dashed line. And because it's greater than, all of this up here is a solution. We're going above the line. Okay. So the two things you need to worry about when we're graphing these compared to an equation. First of all, is it going to be a dashed line or solid line? If it's a greater than or less than, it's a dashed line. Again, it's like a bunch of open circles. And then the shading. Instead of shading left and right, we shade up and down. See you next time.